Automotive Cybersecurity Awareness Improvement Education. Understanding Standards for Automotive Cybersecurity 1. Automobile manufacturers' cybersecurity activities over the entire vehicle lifecycle, from development through production, operation, and decommissioning, are defined. And after operation of a cybersecurity management system has been established, cybersecurity activities must be carried out. In order to do so, automobile manufacturers follow the international standard ISO SAE 21434. In order to allow automobile manufacturer to satisfy the expectations of international regulation UNECE WP29 R155 and allow for a systematic and consistent approach to cybersecurity engineering, guidelines and requirements are provided by the international standard ISO SAE 21434, as we will examine now. In this lesson, we will learn about Introduction of Automotive Cybersecurity Standard ISO SAE 21434, Organizational Cybersecurity Management, Project-Dependent Cybersecurity Management, Distributed Cybersecurity Activities, and Continual Cybersecurity Activities. Please check the educational goals. Introduction of Automotive Cybersecurity Standard ISO SAE 21434. Now we will learn about the ISO SAE 21434 International Standard for Automotive Cybersecurity. This international standard on automotive cybersecurity is composed of 15 clauses. As was previously explained, the ISO SAE 21434 standard defines cybersecurity issues for the entire vehicle lifecycle, from concept to decommissioning, and covers the roles and responsibilities of various stakeholders, including automobile manufacturers, OEMs, and automobile parts suppliers, tier companies. To examine the contents of each clause, Clause 4 covers general considerations and includes the context and perspective of the standard's approach to road vehicles and cybersecurity engineering. Clause 5 covers organizational cybersecurity management and the requirements of organizational cybersecurity policies, rules, and processes. Clause 6 covers project-dependent cybersecurity management, including cybersecurity management and cybersecurity activities at the project level. Clause 7 includes requirements for distribution of responsibility for cybersecurity activities between customer and supplier. And Clause 8 includes activities for providing information on ongoing risk assessments and defines vulnerability management of electrical, electronic, EE systems until the end of cybersecurity support. Clause 9 includes activities that determine cybersecurity risks, cybersecurity goals, and cybersecurity requirements. And Clause 10 includes activities that define cybersecurity specifications and implement and verify cybersecurity requirements. Moving on, Clause 11 includes the cybersecurity validation of an item at the vehicle level. Clause 12 includes the cybersecurity-related aspects of manufacturing and assembly of an item or component. And Clause 13 includes activities related to cybersecurity incident response and updating an item or component. Clause 14 includes cybersecurity considerations for end-of-support and decommissioning of an item or component. And Clause 15 includes modular methods for analysis and assessment to determine the degree of cybersecurity risk. The ISO SAE 21434 International Standard for Cybersecurity covers a complete lifecycle management cycle, and in particular, the development area applies a V-model development process. Here, V-model means an expansion of the waterfall model for software development. To understand cybersecurity standards more easily, we will focus on looking at the major categories and content. Organizational Cybersecurity Management. Organizational cybersecurity management is centered on strong cybersecurity policies and the establishment of rules and processes, organizations, resources, and communication channels, creating a cybersecurity ecosystem. In addition, in order to manage this ecosystem more systematically, management systems, tool management, and information security management are included. And lastly, it includes cybersecurity audits to determine whether the goals of the document are being met at the organizational level. Organizing cybersecurity governance is an area that requires efforts from the entire company that must be established first before cybersecurity activities can be carried out. Beginning with the executive management's commitment to cybersecurity, strong cybersecurity policy must be established, and centered on these, rules and processes, organizations, resources, and communication channels must be established to provide a basis for carrying out cybersecurity activities. Once governance is organized, in order to foster a cybersecurity culture, the activities that must be carried out by the entire company must be explicitly described. For example, there can be security campaigns and continuing capability and awareness programs. Cybersecurity information sharing is a description of information sharing methods and management, such as policies, processes, requirements, and guidelines for cybersecurity information. Definitions of situations in which cybersecurity information sharing inside and outside of an organization is required, permitted, or prohibited are shown on the screen. In particular, the section on sharing of cybersecurity information is important and covers methods for sharing information on vulnerabilities within the supply chain and methods for managing shared information, etc., as well as processes and policies for preparing security incidents. Information security management considerations for shared data can be seen on the screen. For a cybersecurity management system, establishment of a quality management system conforming to international standards and a cybersecurity management system for the production process are recommended. This is an indication that these areas are closely connected to cybersecurity and are recognized as being governed by other international standards, and also means that the establishment of a production process management system is necessary. The core of cybersecurity tool management is the idea that tools may affect cybersecurity must be managed, and that the environment required for cybersecurity incident remediation measures must be maintained until the end of cybersecurity support. Next is content on cybersecurity information security management and concepts for the management of cybersecurity products, including guidelines for handling of cybersecurity products and methods for protecting sensitive cybersecurity products and the establishment of management standards. Last is the organizational cybersecurity audit. The subject of a cybersecurity audit is the organization, and in order to carry out a cybersecurity audit, it is necessary to prepare in advance for the independence of the audit, preparations, planning, execution, and results. Project-dependent cybersecurity management. In cybersecurity project management, whether an item is related to cybersecurity is checked. Then, if it is related, a cybersecurity plan is drawn up and through pre-development tailoring activities, reuse, component out of text, off-the-shelf component, updates, and so on are considered, and a decision is made on whether to integrate it. Responsibility for cybersecurity is outlined in Clause 5 on Organizational Cybersecurity Management, covering the establishment of organizations on the project level within the organization and the preparation of support and tools. Next, we will look at cybersecurity planning, centered on an organization built on the project level to decide whether to carry out cybersecurity activities for an item and drawing up plans. First, based on the review of cybersecurity relevance, Annex D, 4 questions are used to determine whether to carry out cybersecurity activities for an item. If it has cybersecurity relevance, Next, the development status of the item is reviewed and cybersecurity planning is carried out. The content of a cybersecurity plan includes, first, the objective of cybersecurity activities. Second, dependencies on other activities or information. Third, personnel responsible for cybersecurity activities. Fourth, resources required for cybersecurity activities. Fifth, the starting point, end point, or expected duration of cybersecurity activities. And sixth, an identification of the cybersecurity work products to be produced. In addition, a decision needs to be made on whether to tailor an item. Here, tailoring is a development method for adjusting the existing processes, techniques, and work products to fit the situation of the project, and it is a method for project optimization. If tailoring is applied, sufficient grounds for achieving the objectives of the document are supplied and reviewed, and these are reflected in the planning documents. Components to which tailoring, which was described earlier, can be applied are as follows. For reuse components, at the planning stage, a decision on whether to newly develop or reuse an item and a reuse analysis regarding cybersecurity must be carried out. Component out of context is developed by a third party under contract based on certain assumptions and provided by an external company, then customized for a product. For example, microcontrollers fall into this category. Off-the-shelf component is not developed for a particular customer and can be used without modifying the design or execution. For example, open-source software components fall into this category. In cybersecurity project management, an important area is cybersecurity cases. A cybersecurity case is based on work products from cybersecurity activities and is a document written to present an argument on cybersecurity. On the basis of work products in accordance with standards, for example, design analyses, and various results, including test results, this document shows that items and components are well integrated and executed. In order to do so, writing the argument is an important task, and it is also subject to review in cybersecurity assessments. If a work product does not meet the requirements of standards, a case that it is insufficient must be written convincingly and in detail. If a cybersecurity incident occurs after development or production, the cybersecurity case can also be used as a legal document showing that the best efforts were made. The subject of a cybersecurity assessment is an item. A decision must be made as to whether to carry out a cybersecurity assessment, and cybersecurity is checked through work products. The scope of assessment is a check of planned work products, risk treatments, and controls for appropriateness and effectiveness. After a cybersecurity assessment, an assessment report is written. This assessment report includes a recommendation for acceptance, conditional acceptance, or rejection of cybersecurity. In the case of conditional acceptance, the conditions that acceptance are contingent on are explained. If the previously mentioned cybersecurity plan and related work products and a cybersecurity case are prepared, then an assessment is carried out to produce a report. This document defines cybersecurity requirements following development, as well as documentation that is necessary to prepare for the production phase. The end of Clause 6 covers release for post-development. This section covers the previously mentioned cybersecurity requirements for post-development and 3 types of work product that are needed before post-development: a cybersecurity case, an assessment report, and documentation of requirements for post-development. These are used to write documentation for release of post-development. Release means that cybersecurity measures have been sufficiently enacted and development processes have been successfully completed. Distributed cybersecurity activities. Clause 7 on distributed cybersecurity activities clearly defines the OEM and tier company's responsibilities for cybersecurity activities. This chart shows the relationship between customers and suppliers. If the customer is an OEM, then the supplier is Tier 1. If a Tier 1 company makes a contract with a Tier 2 company, then the Tier 1 company is the customer and the Tier 2 company becomes the supplier. For distribution of responsibilities with the candidate supplier, the customer must assess the supplier's capabilities for carrying out development and post-production activities, and the supplier receiving the assessment must provide records on its cybersecurity capability to the customer. Records of cybersecurity activities may include evidence that the organization has cybersecurity capabilities, evidence of continuing cybersecurity activities and response to cybersecurity incidents, and a summary of previous cybersecurity assessment reports. After assessing the supplier's cybersecurity capability, the customer requests a quotation. The quotation includes an official request for compliance with ISO SAE 21434 and as an agreement defining the scope of responsibilities for cybersecurity activities by the customer and the supplier. A CIA is the basis for the supplier's compliance with cybersecurity activities. It includes information on cybersecurity goals and cybersecurity requests relating to the supplier's products, such as items and components. After selecting a supplier, the customer establishes a CIA between the companies to align their cybersecurity activities and responsibilities. CIA stands for Cybersecurity Interface Agreement and is a documentation of agreements between the customer and supplier on the distribution of cybersecurity activities. In the CIA, distributed cybersecurity activities are defined, and the main content to be included in the CIA is a selection of personnel responsible for cybersecurity for the customer and supplier, a differentiation of cybersecurity activities to be carried out by the customer and supplier, information sharing and work products, milestones for cybersecurity activities, and a definition of the end of cybersecurity support for the product. The CIA must be mutually agreed to before the start of distributed cybersecurity activities, and in the event that vulnerabilities which need to be managed are discovered, the customer and supplier must agree on the responsibility for the measures to be taken. In the process of agreeing to a CIA, if the requirements are unclear, cannot be carried out, or conflict with other requirements, then the customer and supplier must allow for appropriate decisions and measures to be made. An appropriate agreement must be made to decide on appropriate roles and responsibilities for cybersecurity, and cybersecurity activities must be carried out according to these. Finally, the definitions of responsibilities for the customer and supplier must be clearly expressed in a cybersecurity interface. Continual cybersecurity activities. According to Clause 8 on continual cybersecurity activities, if information collected through post-development monitoring activities might affect the assets of an item, this must be effectively managed or tracked. In the monitoring stage, after sources for information collection have been selected, information related to items is categorized as an event based on defined triggers. At the event stage, if evaluation reveals threat scenarios related to the resources of an item, it is identified as a weakness. Architecture analysis, attack path analysis, or an evaluation of attack feasibility can be used to identify vulnerabilities. If there is no attack path or the attack feasibility is very low, the weakness is not classified as a vulnerability. Weaknesses that are not classified as vulnerabilities must have theoretical justification provided as to why they are not vulnerabilities. If a weakness has one or more attack path and the attack feasibility is low or higher, it is identified as a vulnerability. Vulnerabilities undergo a risk treatment decision and are handled in one of 5 ways. reduce, retain, share, avoid, or incident response. Now we will summarize and end this education lesson.